Marcus Bulstrode, Senior Development Officer at DAF in South Johnston, far north Queensland, has spent the better part of his life working in the natural environment. Inspired by a conversation with Dick Camilleri about developing a small aerial spot spraying system, the rest is, well, what you're going to hear today. Please make him feel welcome on the stage.
Okay, good morning. Some of you do know me already. I've flown many blocks and many farms over the last few years. Well, I am interested, first off, if I could just get people that have been involved with the drone technology or perhaps have a drone in their farming system, if you could just put your hands up for me. Okay, that's particularly interesting because I've been doing this for a number of years, and when I first used to talk, there was just absolutely no one. Everyone was interested in drones, but certainly no one had a drone or had utilised drones in their farming systems. So it's good to see that it's getting going. No, that should be next, I think. Can fly a drone, but can't push the right button. There we go. Okay, so the few things that I'm going to talk about during my talk. There we are, there's a bit of a delay. I might just go back a touch. Wait for it to come through. All right, so I'm going to talk about the evolution of drones. Is that the one that's up there? Yes. Yeah. Evolution of drones technology over the last few years, what drones are doing in coastal cropping systems, and where the technology is heading, which is a very fascinating part of the way things are at the moment. Let's see whether I can get this to do it. Okay, just to give you a bit of an idea where in DAF I fit. So I obviously work for the Department of Agriculture and Fisheries, and I work for Agriscience Queensland, which is a work group within the Department of Agriculture, and I work for sustainable farming systems, and in particular I am involved with research, development and extension. And I'm based at the South Johnston Research Station up in the wet tropics region, just a little bit south of Cairns. And my job is to support industry and growers to develop and support farming practices that improve Great Barrier Reef water quality with assessing and promoting precision agriculture. Okay, when it comes to precision agriculture, there are many tools available for us already, whether we're out there in a GPS-guided tractor or whether we've got a smart implement that can do variable rate or a particular activity. We've got multiple types of software, whether it's our farm management software, our tractor management software, but there's also drones, and drones increasingly are filling a particularly important part of precision ag. Now, one thing I have found is that having a few drones does make you very popular. People are interested in drones, and if you want to generate a crowd, put a few drones out and people seem to like to come along and find out about it. And the other thing that I've discovered is that there seems to be a very strong correlation between the size of the drone that you're presenting to people and the interest that growers have. You will notice out the front there at the moment I've got this large spray drone, and I'm always amazed that I can go along to a field day and I've got one of my little mapping drones and a few people drift past. If I take that one along, there's just a crowd of people asking me questions about it. Now, one of the interesting parts about being someone that's involved in drones and flying them almost daily is that my office looks like this. It's really about the mapping. The drones do their thing, but they really give me access to this wide range of maps, and that's the very important part of the drone technology. Some drones can go out and do a job, such as a spray drone, but in particular it's the mapping that I'm interested in. Now, I started about 7 years ago with drones, and back in those days you had to get one, solder it all up, put the thing together and then fly it, and they were very, very unreliable. Sometimes they would just simply fly off and crash into the trees. We also had to get cameras and hack the software of cameras to be able to get them to take photographs at the right intervals. Over the last few years, things have completely changed. There's now a wide range of drones that are available, particularly in the mapping space, and most of these are off the shelf. You can go into somewhere like Harvey Norman's or wherever you like, buy a drone that could come straight out of the box for about $2,500. This is a precision machine that has a 20 megapixel camera, and the camera is built into it. No longer do we need to add cameras to them. They come with the system, all fully functional, ready to go. These are the consumer level drones. We can also add additional cameras if we wish. Some people add multispectral cameras, which is something that I also do. But really, it's the standard RGB, so the red, green, blue camera that comes with the drone, is the most useful tool for the majority of growers. Over the last few months, there's been some slight developments in the hardware side of the technology, and really the hardware is quite mature and has stabilised. That the drone that I was flying a couple of years ago is really very similar to the drone that I'm flying now. One of the slight differences is that perhaps the camera that I used to add on separately has now been incorporated into that drone, and it comes out of the box with that camera on it. And an example here would be that a multispectral camera now is available in a standard out-of-the-box type of drone, and also one that I've got recently is a thermal camera built into the drone. A few years ago it was perhaps $8,000 to get a thermal camera, and now I can get a drone with a red, green, blue camera and a thermal camera for less than $5,000. All right, so as I said, it's all about the mapping, and what I want the drone to do is to go out and do a gridded flight and just to come back and land, and I end up with that data set. The apps that fly and control the drones these days are very, very easy, and most of them are app-based, so that I can simply use an iPad or an iPhone. The app that you're looking here at the moment is a free app that comes with the people that do the actual stitching of the imagery, but there's a whole range of apps available depending on what you need to do. These apps are actually really intelligent as well. This particular app that we're looking at the moment, this flight program, it does a cross-grid, and it also does a perimeter flight with the camera at a different angle, which can then all be stitched together. So if I'm wanting to create a 3D surface model of the block that I'm interested in, this particular flight program can do that. So I set up my flight program, takes a few minutes. The drone takes off by itself. It's all autonomous flight, so it takes off, flies around, does its mapping run. If during that flight it realises, oh, I need another battery, it'll just come and land beside me. I put another battery in again. The drone then takes off automatically again and continues its mission from the last photograph that it took. And then when it's all done, it comes and lands on the ground. What this means is that the skill that I need to be able to fly a drone is not very high at all, because most of it is autonomous flight. With the CASA regulations, you need to be able to control the drone properly if you need to take over manually. But in agriculture, the majority of the flights that you're going to be doing are these autonomous flights off these flight apps. All right, so the drone's come back, did its flying mission. Maybe that took 20 minutes or so to fly the 30 or 40 hectares that I'm interested in. I then end up with an SD card, which I take out of the drone, and I put that into my desktop machine onto some sort of program that can actually stitch those images together. One photograph is interesting, some video is very interesting, but the most powerful tool is when I get all of those photographs, and it can be hundreds from a flight, and I stitch them all together into a single map of the block that I'm interested in. Another way of doing it, I can do it either on my desktop machine. Some of this software is quite expensive and also requires a reasonably powerful computer, or I can now upload it to the cloud. So it means that I've taken my SD card out of my drone, put it into my laptop, uploaded it to the cloud, and there's service providers now on the cloud who do that processing for me. And in this case, I get an email back the next day and it says, yes, Marcus, your maps are ready for you. In the mapping side of things, there's 4 basic products that we're interested in. The Ortho Mosaic, which is just the colour image of the farm or the paddock. Remembering that this is a very high resolution image. It's not like Google Earth. This is down to perhaps 2 centimetre resolution, depending on the altitude that I've flown at. The software can run it through an algorithm to be able to bring out the character that I'm interested in, and that could be something like crop variability. This one here is an output where it's showing you plant health. So it's saying red, for example, are the areas that are poorer within that block, and green are the areas that are producing better. So straight away, I've got something that I can say, and very easily, I've got something, I know that I've got variability within that block, and I can now think about why. Why have I got a different crop health and yield across that block? The other thing I get is a digital surface model. This is basically a 3D representation of the crop, and this is very powerful in linking back to my crop health. So if my crop health says that I've got a very poor zone, I would anticipate that that zone is going to be lower and more open than the zones that are showing the better crop growth. The other thing I get is a full 3D model, which I don't know that all of you have seen 3D models, but for those that have, you'll understand that you can rotate it around, zoom in and out, and interrogate that particular block really, really well. I just want to show you here why I've got a 3D product from it. And this is hopefully it's a video that's going to play on a 3D point cloud. Just give it a moment longer to go. Let's see what happens. Okay, so all photographs, digital images, are made up of colour pixels. They're, in some cases, millions of colour pixels per photograph that's taken digitally. All of those pixels are basically in 2 dimensions to start with, but as soon as I get multiple images, I can triangulate where those pixels are, and I can create a 3-dimensional image from multiple images. And this is the sort of powerful side of the drone technology, the photogrammetry that goes with the drone technology, that allows me to do a lot of other things. All right, one of the things I have become particularly aware of is the level of variability across cane growing areas and cane growing farms. It's just staggering that all the years went by where I'd sort of drive around someone's cane block and say, yeah, looks pretty good crop, pretty even. These days, that's a completely different story. The majority of blocks have some level of variability, and a lot of blocks have a huge amount of variability. Here we have what we call the Ortho Mosaic, so just the normal colour image, and straight away I can see that I've got some significant variability across this block. This is a mixed species fallow crop. I run it through the crop health filter, and there it is, so strongly shown for me to be able to understand exactly where I've got that difference within the block. And that then allows me to do a whole range of things to try and work out why. Why have I got that variability, and how can I either improve that variability, or how can I look at being able to match the inputs to the potential yield of that zone within the block? That can be a whole range of things, from soil analysis to working out what sort of drainage I've got across the block, and we'll do a little bit on drainage in a moment. I may send away tissue samples to get analysis, but I can start the journey of trying to understand why I've got that variability. So some of the benefits that can come from it are identifying poor yielding areas, identifying low and poorly drained zones, identifying pest and disease problems across the farm, helping in selecting where to take soil samples. So you think about it, when you go out to take a soil sample across a block, what sort of process do you go through to work out what areas do you take soil samples of? And if you're taking multiple soil samples, then you've got a blend across the block, but it's not necessarily representing those zones of difference within that block. So what might be more appropriate is to say, I've got a couple of very significantly different zones within that block, and I'll do specific soil samples, still multiple sites, but within that zone. I'll have them assessed and try and understand if that's contributing to my low yield. All right, so at the moment, the majority of growers deal with a block as a single management unit. With this sort of technology and this concept, and we already heard some wonderful presentations yesterday about people that are already out there doing variable rate application, but this technology is an easy step into being able to do variable rate application, or to being able to understand those zones of difference. Here we have a block where it was, we had EM mapping done. We also did the full mapping with the drone over a period of time. It informed where the soil tests were taken across this particular block. And in the end, what we ended up doing was doing zonal application of mud. So we've got banded mud, which we've seen presentations on, which is obviously a fantastic way to go about it. But we've got another layer above that or below that, which is zonal, so banded, but even zonal. So I've got a certain amount of mud to put out. I've got a certain amount of the country that needs mud on it, and I can now come up with a prescription map to be able to apply that mud even more precisely across the farm. Here we have a legume fallow, and we can look at, once again, in the Ortho Mosaic, we can already see with our own eyes that there's some variability going on. When I look at the crop health, it's very clearly shown, and then I can sort of even block it up a little bit more so that I've got very specific zones to be able to deal with. So straight away, I've got a process where I can make better management decisions because I understand more about what the crop has done. And in this case, here's an example where a grower would be looking at adjusting his plant rate, fertiliser rate, but he's trying to make some sort of decision based on the block, and he might be standing in an area where the legumes are this high, but there's a whole lot of areas where the legumes are right down here. So he needs to be able to make a decision based on the whole block, unless he's able to do zonal application, which is obviously the best way to go. And if he is doing zonal application of the fertiliser, he can now match it. All right, the other thing that we can do a lot with is in weed mapping. So there's a whole range of things from the fertiliser and the soil ameliorant aspect of it, variable rate, right through to mapping our weeds. And here we have an example of Guinea grass. And this is Guinea grass at about 2 weeks after harvest. That's a time where the Guinea grass stools present themselves quite clearly. We can zoom in on it to get a bit of a feel for, we can't necessarily tell from the imagery that it is Guinea grass. Obviously this was because I walked into the block and had a look at it. But I can use my crop health filter to be able to say, all right, well, if I've got something much greener growing up in what's basically a trash-covered block, I should be able to see it there, and I can. I can also run my digital surface model over it to say, when I was standing there in the block, these Guinea grass stools were significantly higher than anything else in the paddock. So there we are, I can see them in the digital surface model. Here's an example where I remotely mapped the Guinea grass stools for a grower and marked them and gave him the map where they were. If you look into this one on the red marker, you can see that there's one that he's gone in and sprayed out. The yellow one indicates a stool that was missed. So that's from a subsequent flight. Then I was able to do another mapping exercise where I could show all the ones that had been sprayed, the ones that he had missed, and the new ones that were coming through from some cane that was cut a little bit later on. So this is a process where we can start to assess the weed pressure within a block, but we can also look over it multiple years to see whether you're sort of working yourself out of that weed or whether it's actually continuing and what your management activity is not really controlling it. Here we have vines. So this is vines in out-of-hand cane, so big cane, can't get any ground-based equipment over it. The option is, first off, for the grower, and the reason I flew this block is the grower said, well, how much have I got in there? What sort of a problem do I have? Relatively easy fly over, I can tell what the vine load is. In this case, it was widely distributed across the block, so it's a bit of a challenge. It's not just one area, and it's something that ended up being dealt with an aircraft, a manned aircraft. I can then do a subsequent flight to say, in this one here, we're looking at, I've zoomed right in to see the vine patch, and I can even tell the grower what species of vine it is. But then here I've flown afterwards to see, all right, what sort of success was that flight? Has all the vine been removed? But in particular, what damage has been done to the crop? How much of the stool has been lost by the vine? Crop health filter, once again, I can have a look to see it again represented there. Another thing that we're experimenting with at the moment, we've done a few trials with it, is in grub mapping. And Daniel, who's my colleague here in Mackay, we've done a bit down here as well as the stuff up in North Queensland or up in the wet tropics. And grubs have a particular look from the air when the cane has lodged or fallen sprawled from the cane grub damage. And we've been able to pick it up in the crop health mapping, been able to get sort of that zonal look to it. And the idea here is that if we can understand where the grub pressure is within a block, well then we can actually apply imidacloprid to that zone in particular, and obviously a bit more than that zone, but we know where the grub pressure is and we can start to target particularly problematic chemicals that we know that there are reef water qualities around and we need to find ways to be able to sort of tighten things up a little bit. So this is perhaps going to be an approach where we can target it even better. Here we have an example of irrigation. This is a centre pivot, but it has drips on the corners, so drip lines at the corners, and a very sort of complex system, and they had all sorts of yield variation going across the block, and they asked me to fly it. This is up on the Atherton tablelands. And another one where we can see very clearly, straight through with the crop health or plant health filter, we can see straight away where the zones, the poorer zones are within. In this case, some of them are within the centre pivot area and the other areas which are within the drip line area where they could potentially either increase or decrease the water they're applying. And on the other end of this block that you can't see, for instance, they had a zone where they were applying too much water. It still looked like that, like this bottom corner. It still looked yellow and poor, but when we got into the paddock and had a look, it was actually waterlogged. So one end was dry, the other end was actually waterlogged. All right, so here's an example of some of the standard outputs that I've mentioned earlier. So we've got the Ortho Mosaic, we've got the crop or the plant health filter, we've got the digital surface model showing up the variability. And one of the latest ones that I'm experimenting with is thermal. As I mentioned earlier on, I've just recently got a less than $5,000 thermal addition to a drone, and I'm seeing a remarkable correlation between thermal and the plant health. And it makes sense that we've had some particularly hot weather. It's been up around the 40s and things like that. When we're looking at transpiration of the plant, it's keeping it slightly cooler, and wherever it's not able to get either access enough water or to be healthy enough to perform good transpiration, it's going to end up warmer. So it's showing up as another tool, another way of being able to say, I can see that variability and I have some understanding of why it's occurring. All right, that's sort of the standard mapping products. This is open to pretty much all growers. A grower can go out and buy a $2,500 drone, probably wants to add a couple of batteries, perhaps a box to protect it, jumps up the price. He's maybe still looking at less than $5,000 and he's got himself a mapping drone. A yearly subscription online is about $1,500. So there are all the things that go together, and a grower, depending on the farm size or depending on the problems that are associated with that farm, it becomes a very affordable way to be able to manage some of those problems. But there are many advanced tools. Here we're looking at that digital surface model and that point cloud that I showed you. So this is software that allows me to create contours across a farm, to be able to create drainage maps to show where the water is draining out across the farm, to either manage that runoff if it's a sediment load, but also to be able to reduce those concentration zones. Here we have an example where a farm was mapped. It has flumes on it to assess water quality, and an early flight showed that the relocation of one of the flumes would actually increase the catchment area for that flume. So this is down to sort of a couple of centimetres level accuracy using RTK correction, but these are the sorts of things that are available at the next level up with the software. Not for all growers, but this is the potential of the technology. Here we have, I've done many crops, not just cane. I do mainly cane, but because of where I'm placed, I've been fortunate enough to be able to do a wide range of crops. This is bananas, this is TR4. So here's an example where a TR4 infected plant was able to be identified, but without anyone entering the farm. Was done on a hillside adjacent to it, didn't need to go on the farm, flew the machine over the top of the crop and able to come down and identify an infected plant. It still requires someone to go in and actually take a sample from it, but at least people didn't have to walk around all over the farm in that initial identification. Okay, the next thing, and getting towards the end of it now, is on the spray drone side of it. I mentioned I had a spray drone out the front there. This is a collaborative project that I have with Innisfail cane growers. It's a 3-year project where we've purchased a spray drone, a large spray drone, and we're trialling it over a number of years to see how effective this technology is. And so far it does a very, very good job. Very smart and accurate machine. And I do a mapping mission in advance with my small mapping drone, and then the large machine, which has a very low flight time, goes out and just flies straight onto the target and delivers the herbicide. And it is smart enough to know when it's within the polygon to spray, when it's got one of its boom parts that are outside the polygon. If its tank gets low, a bit like the mapping drone, it'll come back and land. I put a more herbicide into it or put another battery in, and it goes back to where it was spraying last and continues the mission. Flies for 10 minutes. This is not something that you use for big areas. The idea is that it's in something like the vine in the out-of-hand cane. I've got a few patches of vine. I don't want it to seed. I don't necessarily need to get a manned aircraft in. Here's a way of being able to treat that. In China, they do lots of it. In Australia, it's still a very small part of the industry. I'll just run this video just to give you a bit of an idea of what this project is. My name's Marcus Bulstrode and I work for the Queensland Department of Agriculture and Fisheries. I'm a cane extension officer and I work with cane growers to support them improving their practices to improve Great Barrier Reef water quality. This machine is a herbicide or pesticide spray drone. We've mapped some patches of weed within the paddock earlier, and this machine is capable of going out and just spraying those patches. So we can use a fraction of the chemical that we did previously. The project that I have going at the moment is a 3-year project in collaboration with Indusvale cane growers. Jointly between DAF and cane growers, we've come up with a plan to have this particular machine spray vines in cane, so red convolvulus in particular. If we look here, there's a creek just very close to the cane paddock. So potentially anything that's applied to this paddock here could end up in this waterway, moving its way to the Great Barrier Reef. So if we can reduce the amount of herbicide and pesticides we put on the cane, that's going to improve reef water quality. Being able to spray weeds from a drone really began with Dick Camilleri, who's a cane farmer from the region, and some years ago he had the idea that instead of spraying basically the whole paddock, if he could just go out and target the weeds, he would be able to greatly reduce the amount of herbicide that he puts out. It took a couple of years to get that machine going, and during that time commercial products became available. This machine is a DJI product. It comes out of China, and basically it's an out-of-the-box, ready-to-fly spray drone. Over the last few months, we've been working with this machine just to make it a little bit better suited to the environment we have here in the wet tropics. So what I'm going to do now is put some water into the machine and run it through the sprayers. The machine is fitted with 4 spray nozzles. Pairs of these nozzles can be turned off independently. We have changed the spray nozzles in this machine to optimise the droplet size for the spray activity we're doing. The nozzle is a very, very important part of it, and without the right nozzle you can be putting out spray either too much, too little, without any real effect. Prior to going out with the spray drone, I take out a much smaller machine, which is a machine designed for mapping. Very quickly I can just roll into the image. It's a very high resolution image. On the ground I can see an object of 2 centimetres. You can see the area that does have the vine in it. We'll see that the rest of the block is actually quite clean. This is exactly the sort of thing that the machine is built for. It can go in and fly this zone only. I've been able to put its flight path over the top of the area that we know the vine is in, and so the machine will actually move up and down these rows, spraying as it goes to take out the vine. With a full tank of herbicide, which is 10 litres, it can fly for approximately 10 minutes. So that means that you pre-map the area, you know where the weeds are, you set up a polygon for the machine to fly, so that's an area for it to target with its spray. The machine will take off and then go directly to those patches and spray them very quickly and of course return. So though you're only flying for 10 minutes, which seems a very short period of time, you've done a lot of the background work to reduce the time this machine's in the air, and it does its spraying very quickly. One of the advantages of this machine is that you can get onto the particular cane block at any time of the year, whether it's wet or dry. And of course, it can actually force down the droplets down through the cane to be able to get onto the target weed. When I finish spraying, I can actually get the hose and hose it down, which always feels a little bit strange with a very sophisticated bit of equipment to be putting the hose on it. But once again, it's built for the job. This size drone, and because it's putting out a registered chemical, requires very specific accreditation and licensing. This is not a machine for everyone to be able to fly. You have to have that correct licensing. I would picture in the future that cane cooperative groups may own a machine, or possibly contractors who will have the correct licensing and then come out and be able to do the spray activity. Okay, so that's the spray drone side of it. Now I'll just end off on where the technology is going, and where it's going, it's already begun at. So we're already looking at AI within the photogrammetry, the processing of the images from the drone. The best way to show it is perhaps something like this, which is an automated weed mapping software. And at the moment, I do things manually. So I go into the image and I identify where those particular weed patches and what the species are within the image. I can actually put it through something like this software, and the software will actually identify the areas for me. So it not only comes up with, we can see in the report at the side of it, it also comes up with the area that's covered. So if I'm a manager and I want to make a decision on a block, it'll actually show me, all right, well, I've got 5% of the block is affected by whatever it is. It also works with, and I've been doing a lot of that just recently with MSF, is the gap analysis. So they put out a plant crop, and then they have a look to see, wow, we've got gaps in it. Why have we got gaps? So first off, they know where the gaps are, they know how many gaps, they know the percentage of gaps across the block, and they can start to deal with those issues. And this also occurs with subsequent crops, so through the ratoons, to make decisions on when am I going to knock out that crop. So to have a bit of a look at it, yeah, I've got a bit of a feeling for maybe it's starting to get a bit gappy and it's maybe time to knock it out. Fly it with the drone, either through the automated software or just looking at it with your eye. You can start to make decisions on what you need to do with that block in the future, whether it's time to turn it into a fallow or knock it out. The AI side of it is just beginning. There are a range of products which I've been testing which do work. There's some that are cloud-based. What the technology is trying to do, it's saying to the grower or the industry that the more images you give me, the smarter the software is. So that if I've got a weed and it's an overcast day, then it's a sunny day, and I've got all these different things going on, the software can have challenges trying to find it. But the more examples that I show the software of the variation that can be within that character, that thing I'm interested in, the more intelligent it becomes. So the future is certainly many more AI-based automated software systems. That's something that we're going to see. And the other thing that we're starting to see a lot now of is the integration between the drone-based images that are created, the maps, and tractor software. So if you're doing something like John Deere system, you can go in through John Deere, My John Deere, bring in whatever type of mapping you've got, just put it into the right file format to go into your My John Deere, and it has the capacity to be sent straight to the tractor. So these bigger companies are building the ability in to be able to bring external mapping products into their tractor guidance systems and their farm management systems. Let's go back one. All right, so that's basically my talk for today. Just to give you a bit of an overview of drone technology, not to sort of get too heavy on it. I've got the large spray drone out the front, and if anyone wants to have a chat to me at some stage, please just come along and I can explain it a little bit further to you.
Thank Marcus Bulstrode. Now, we are running a little bit behind time, but I think we can absorb it. Is there anyone who has some pressing questions they'd like? I'll take two from the floor. Hands up. About what you've just seen? Graham, fantastic.
Marcus, I just wondered how far you think we are from the point where you can have pixelation with the cameras, that you can analyse chlorophyll and pick up immediately that you need some boron, some molybdenum and some zinc, for example, through one flyover. Is that close?
No.
It's not?
No, I think that's a long way off.
Okay.
There is hyperspectral, which has the potential to do that. When we're looking at RGB and even through multispectral stuff, it's not really going to have that capability of focusing into a specific element that's perhaps missing. But hyperspectral may do that, but hyperspectral is very, very expensive. So I'm not saying that it won't become cheaper and more available, but at the moment, that would be a very big step away. The real power of it is to be able to begin the process through this so that I know I've got that zone, and then perhaps go in on the ground and start to make those investigations.
Thank you.
One more? Ooh, who's the lucky contender? I'll take two. I'll take you both. I'll come and see you, Joe. If you just grab that one, Ross.
Have you done any work with identifying YCS in cane or anything like that with drones?
Yes, I have done some, and it's remarkably uniform. So it's not a. So yes, I have. I won't say I've done a lot of it, but I have done some examples of blocks that have it. But so far, it's been reasonably uniform. So yes, you can see that, say, compared to an adjacent block that is not affected, it's definitely showing that it's a less healthy block because of the yellowness. But when it comes to, is there any remarkable pattern across the block, something that might unlock the story to it, I haven't seen that so far. And I would hope that in the future we'll get to fly many more blocks and perhaps start to find something like that within it.
Marcus, in relation to the fact that I'm an old fart, where do we go and where are we in the development of this process to work through from the economics of either owning and doing your own support and your own work, as opposed to utilising support as in contractors and such?
So my view is that there's sort of different layers, different entry points you can go to. Obviously, we've got Brian here somewhere. There are people who are doing it extremely well, fantastic level of being able to do it, get a contractor in to do it, and there are other people doing that. To me, it's become such an accessible tool that if I had a cane farm, I'd have a drone, I'd go to Harvey Norman's, buy a drone and be flying it the next day to have a bit of a look to see what's going on. If I got pigs down the bottom corner digging it up, I want to know those sorts of things. So it depends on sort of where you're wanting to go with that journey of exploring it. But the technology is particularly accessible to old farts. I'm probably almost fitting that category up these days. All of it's available to, because really, I like to think of it as that with some technologies they're coming towards you as you're going towards them. And there's no doubt that with the drone technology, a lot of the app-based stuff, it's just so easy. It's intuitive. You don't need to have some great background understanding of technology to do it. And I mentioned that most of those flights are automated. It would take me 5 minutes, 2 minutes to arrive somewhere with my iPad, bring up my Google Earth shot, touch the corners of the block, send that information to the drone. The drone does all the rest of it. It works out, okay, I'll need to fly this many grid lines to get the overlap to, I need to fly at this altitude. And then from then on, it's fully automated. I stand back, push the button, it takes off, flies around, does it, and comes back. So I guess what I'm suggesting to you there is that, first off, there's not a technology barrier as far as I'm concerned with it. DAF's happy to help you. There's a lot of other resources to help you. If you've got sort of really complex issues, I would suggest that it's the agronomy side of things that you engage with to be able to deal with it. But the technology is definitely accessible to all of us and quite affordable. I think when you start to look at the economic side of it, a few good decisions made from the data that the drone provides would easily cover, I would think, the cost of the machine.
One more question.
Mark, just with your drones and your maps and all that, it's good to have pretty maps and all that, but you still need someone there to determine what fertiliser, you still need that second part to it, don't you?
Yes, and a very big yes to that one, that this gives you the map that indicates I've got a problem, and then you need to get the right people to be able to work that out, and that can be the farmer, and it can be through advice through an agronomist and other experts, so definitely.
I'd like to advise the Speaker that was actually a statement, not a question, but I'm glad you said yes. Now, I want to make one more thing very clear, because last night after Graham Sate's presentation, I had growers talking about how interesting it was. He was talking about spraying nitrogen on the leaves. Is that the sort of thing that drones could be doing in the future as well?
Yes, they can be putting out chemicals. The thing is, it's the area that you're trying to do. And if you're looking at a 10-minute flight, for instance, a machine like that with 10 litres on board, that's not really...
Cheaper to get a helicopter.
What's that?
Is it cheaper to get a chopper?
It is. In those cases, much better to get a helicopter. In China, you can fly 6 at the same time. So you can launch 6 off one controller and they go out and they do much bigger areas. But here in Australia, you can't do that. CASA will not allow that. So it's a scale thing that reduces.
Please give him a big round of applause, Marcus. You've been fantastic.